All right, this is your recording for Unit 3, Activities 17 and 18, prior to the second Unit 3 Embedded Assessment Sketch Artist, as well as partially for your Unit 3 test. Just going to go through a couple of these problems, hopefully one of each type of thing that you're going to be expected to do. So the first several problems that we have are asking us to factor. Remember that on a test it will definitely not tell you which type of factoring to use. So make sure that you know how to recognize all the different types that we did in our checklist. All right, so first one I'm going to go through is 3b, which the problem was 14x squared plus 25x plus 6. So I look at it and going through my checklist, first I look for a GCF, so no GCF that I can see. Then I would look for special products. The only type of special products that have 3 terms are PSTs, and I know it's not that because 14 and 6 don't have perfect square roots. So then I move on to see if it could be chart factoring. So I look to see if there are factors that multiply to 14 times 6, which is 84, multiply to 84, and add to 25. So you can go through, if you don't know factors of 84 off the top of your head, just start doing 84 divided by 2, 84 divided by 3, so on and so forth, to try to find some factors. We do have some factors that match up here. 21 times 4 is 84, and 21 plus 4 does add to 25, which means this can be factored under our chart factoring umbrella. Remember that there are 3 different ways that you could potentially factor this. One is via guess and check, where you say, I know there's going to be 2 parentheses. You list out the factors of 14, which are 1 and 14, and 2 and 7. You list out the factors of 6, which could be 1 and 6, or 2 and 3. And then you guess and check. So most of the time, I kind of made those look backward, and just, we'll put it this way, 1 and 6, 2 and 3. So when you are using the guess and check method, I've told you that usually we choose the factors that are closer together first. So I'm going to do 2 and 7, so 2x, 7x in the front, because those are factors of the front. I know that both my signs have to be pluses because both of these are pluses. And so again, I'm going to try the ones that are closer together here with the 2 and the 3. I'm not going to put the 2 with the 2 because that would require a GCF to have been taken out, and there was no GCF. So I'm going to try the 3 here and the 2 here. So I've guessed. Now I need to check it. So firsts would give me 14x squared. That's good. Lasts, 3 times 2 is 6. So I need to check the insides and outsides. Insides give me 21x. Outsides give me 4x. 21x plus 4x is 25x. So I know that that is the correct factorization. So that's one method you could use, listing out the factors like this and then guessing and checking till you get it right. The other method you could use is split the middle or the box. So if you're going to do split the middle, then that means you go to your chart and you split your middle term, which was 25x, into 21x and 4x. So we write 14x squared plus 21x plus 4x plus 6, and then we factor it by grouping. So group the first 2, group the second 2. GCF of the first group here is 7x, which leaves me with 2x plus 3. I know in factoring by grouping that my second parenthesis also has to be 2x plus 3. So I can work backward. What do I multiply 2x by to get 4x? I multiply it by 2. So then again the fronts become 1 parenthesis, 7x plus 2, like this, and then you put in the 2x plus 3. So if you're a split the middle method preferer, There's the work you would show. The third possible way that you could come up with that same answer is by using the box. So if you prefer the box method, remember that the front goes in the top left, the back goes in the bottom right, and then again your chart numbers fill in to the other empty spaces, and then you just take the GCF of each row and column. So this row is 7x. This row's GCF is 2. This row's GCF is 2x. And this row's GCF is 3. So again, you can see here 7x plus 2, 2x plus 3. So regardless of which method you like, that's how you would go through it. Regardless of the method you choose, do not forget to FOIL your answer back out to check it. It is silly to leave factoring problems that you haven't checked because you could know for sure if your answer is right or not. All right. Next, I'm going to look at 4b, which is 12x to the fourth plus 2x cubed minus 30x minus 5. So I go through my checklist. First, I would look for a GCF, which between all four there is none. Now, because this is 4 terms, I know it's not a special product or chart factoring. So if there is no GCF, then that means I'm going to factor by grouping. So just like I did when I split the middle here, I look for the GCF of my first group, which is 2x cubed. So I take that out in front. What do I multiply 2x cubed by to get 12x to the fourth is how I determine what's in my parentheses. That answer is 6x. What do I multiply 2x cubed by to get 2x cubed? That'd be 1. So that's what goes there. Again, I know that my second parenthesis has to be the same, and I can work backward. What do I multiply 6x by to get negative 30x? I multiply it by negative 5. So 2x cubed minus 5 times 6x plus 1 is my factorization. Again, look how quickly you can check. 2x cubed times 6x is 12x to the fourth. Check. Outsides, 2x cubed times 1 is 2x cubed. Check. Insides, negative 5 times 6x is indeed negative 30x. And the negative 5 times 1 is negative 5. So I've just checked and confirmed my answer there for 4b. All right, next one I'm going to look at is number 5a, which is 125x cubed plus 216. So going through my checklist, first thing I do is look for a GCF. There is not one, so then I look for special products. This is 2 terms, so special products is really my only choice after GCF. This can't be a difference of squares because it's a plus, can't be a PST because it's 2 terms, which leaves me with sum of cubes. So in order to be a sum of cubes, both terms have to have a perfect cube root. 125x cubed's cube root is 5x, and 216's cube root is 6. So this is a sum of cubes. So I set up a binomial times a trinomial. I use SOAP to fill in my signs. Same, opposite, always positive. Cube root of 25x cubed is 5x, we said. Cube root of 216 is 6. And now, remember, we don't look back at the original once we have our binomial. We look at the front. We square this front to get the front over here. So 5x, when I square it, is 25x squared. Middle is multiply. So multiply these two together, which gives me 30x. And then to get the back, I square the back. So 6 squared is 36. Remember that we have said that this guy will never factor further. And then you could FOIL, double distribute, not FOIL, but double distribute it back out to check your answer. All right, last one for factoring. I want to look at 6c. It's got a higher order polynomial there. So x to the fourth plus 17x squared plus 60. So first thing I do is look for a GCF. There is none. So then I look for special products. Since this is a trinomial, the only one I would consider is PST. This has a perfect square root, but 60 does not. So it's not a PST, which means I'm now going to look for chart factoring. So I'm looking for factors of 1 times 60, which is 60. So what multiplies to 60 and adds to 17. So you can list out factors of 60 if you want. So let's say you said 2 times 30. Well, that doesn't add to 17. That adds to 32. So then maybe 3 and 20. Well, that adds to 23. Still too big. So 4 and 15. That's 19. We're getting closer. 5 and 12. That is our winner. So again, I don't want you to think that you're always going to get this right the first try when you're looking at your chart. So 5 and 12 are our winning numbers. Now, remember, this one has a leading coefficient of 1, which means this doesn't have to be guess and checked or boxed or split the middle. Doing those things wastes your time. You shouldn't have to guess and check. When the leading coefficient is 1, whatever the winning numbers are in your chart, those make up the ends. So you put the x squared and x squared in the fronts because we know since our middle term has an x squared that that's what our fronts have to be. We know that they're both pluses because these are both pluses. And I just fill in the 5 and the 12. Again, you don't have to split the middle or guess or do a box when that leading coefficient is 1. The winning numbers just are what you put in parentheses. Again, you can quickly FOIL it back out to check that, but that is your correct factorization. This time I would look at each of them since they're each x squared to make sure they didn't factor further. Since these are both binomials, the only way that they would factor any further is if they were a special product. They can't be difference of squares because they don't have minus signs, and they're not sum of cubes because 5 and 12 don't have perfect cube roots. So I know that that is as far as it goes. All right, moving on from the plain old factoring and looking now at our find the zeros. Remember that you have to have algebraic work for this. It says by factoring and using the zero product properties. So I'm going to do 8b here. So your function was g of x equals 3x cubed minus 3. So first thing I need to do is set it equal to 0. Then I need to factor it completely. So going through my factoring checklist, first I look for a GCF. Yes, there is a GCF. They both have a 3 in common. So I pull that out, which would leave me with x cubed minus 1. Then I look at my x cubed minus 1, see if I can factor it further. So because it has 2 terms, I'd only be looking at special products. It's not a difference of squares because x cubed doesn't have a perfect square root. It is a difference of cubes. Both of those have perfect cube roots. So binomial times a trinomial. Cube root of the front goes in the front. Oops, I almost forgot my soap. Same, opposite, always positive. Cube root of the back goes in the back. That's just 1. And now, remember, I get the trinomial from the binomial. So take the front and square it, which gives me x squared. Middle is multiply, so 1x, which is just x. And then square the back to get the back, which is just 1. Remember that I have told you that this trinomial from a sum or difference of cubes is not going to factor any further. So we're ready for the step where we set each factor equal to 0. So x minus 1 equals 0, and x squared plus x plus 1 equals 0. So this one, very easy to solve. I get x equals 1. Over here, I know it's not factorable. I can't solve by square roots because there's a linear term, which means you either need to complete the square or use the quadratic formula. I would use the quadratic formula on this because b is not even, meaning you would have fractions when you were completing the square. But if you prefer that, it will still work. So I'm going to use the quadratic formula. So a value is 1, B is 1, and C is 1. It's unusual. So opposite of B, plus or minus the square root of B squared, which is 1, minus 4 times A times C, all divided by 2 times A. So now I need to simplify it. So I've got negative 1 plus or minus. Within my square root, I've got 1 minus, this is multiplication, so I do that first, which gives me 4. 1 minus 4 is negative 3. On my denominator, 2 times 1 is 2. So now I just need to simplify within my radical. Because there's a negative, that means I should get an I. So plus or minus I, radical 3. Now you would always look to see if your radical simplified. In this case it does not, because 3 is prime. And so 2 is our denominator. So we've got these, which represent 2 zeros, 1, 2, the plus and the minus. Here's a third 0. I know I've found them all because I found 3 zeros, and the degree is 3. All right, next, when we're given the degree and the zeros and we are trying to go backward and get back to what our polynomial looked like. So I'm going to do 12d, where n is equal to 3, so it's telling you the degree is 3. They tell you one of the zeros is x equals negative 2, and they tell you another 0 is 1 plus or minus 2i. Now, the first thing you should do is realize that if 1 plus 2i is a 0, that 1 minus 2i must also be a 0. Now, I showed you 3 different ways that you could show your work for these imaginaries. I'm going to do it the longest way because, again, the other ways require kind of a deeper understanding. So this is, if you have the least amount of understanding of this, this is what you would want to do. Again, if you know the other 2 ways that are kind of less work to write, you are more than welcome to do those. So x equals negative 2 means that x plus 2 is going to be one of our factors. Because we subtract, we change the sign on whatever this is. So for these ones, I would do x minus 1 plus 2i, and I'd do x minus 1 minus 2i, because again, all we're doing is x minus negative 2, which became a plus. We subtract each of the factors. Now, this requires some simplification because you have to distribute the negative. So x minus 1 minus 2i is this guy, and this guy over here is x minus 1 plus 2i. Again, if you know the shortcuts, have at them. If you don't, we said that you always want to FOIL or multiply the imaginaries together first. So to multiply these imaginaries, I'm going to need a box because they're both trinomials. So I have a 9 square box. Doesn't matter which one goes on the top and which one goes on the side. So I'm going to do x minus 1 minus 2i down here. I'm going to do x minus 1 and a positive 2i here. So now row times column, x times x is x squared. Here, x times negative 1 is negative x. This gives me a positive 2ix. Second row, negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Negative 1 times 2i is negative 2i. Last row, negative 2i times x is negative 2ix. Negative 2i times negative 1 is positive 2i. And negative 2i times positive 2i is negative 4i squared. Now, here I have some like terms, and I have some like terms that cancel. These cancel each other out because they're opposites. These cancel each other out because they're opposites. I also should simplify my negative 4i squared because I squared, remember, is negative 1. Negative 4 times negative 1 is positive 4. So I'm replacing this for this. Now I've got like terms here, and like terms here. So this gives me x squared minus 2x, and then 1 plus 4 is 5. Now the reason I wrote it spread out is because I know that now that I've fixed this, I found what these two multiplied together is. Now I need to go back and multiply it by my x plus 2. So I'm making myself another box, a smaller one this time, because it's a binomial times that trinomial. So x and positive 2, so x times x squared is x cubed. X times negative 2x is negative 2x squared. X times 5 is 5x. 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. And 2 times 5 is 10. So, combining my like terms, these guys actually cancel. These guys are like terms, no other like terms. So I end up with my final function, which you can put f of x, g of x, whatever you want to call it. It's x cubed. And then 5x and negative 4x is positive 1x. And then plus my 10. So this is my final answer. Moving along, the next ones in number 13 just gave you some information and asked you to tell what the degree is. So I'm just going to look at 13. See, it did not ask you to write the polynomial, so you don't have to multiply those guys out. But you've got x equals 2i, and then you've got x equals 1 minus 3i. All it wants you to do is tell the degree. Well, you should know that imaginaries always come in pairs. So if this is a 0, that means negative 2i is a 0 also, which means that represents 2 zeros. Same with this. Its complex conjugate 1 plus 3i has to be a 0 as well, which means that there are 4 zeros. Remember that the number of zeros should match the degree, so that is why I put that it had to be degree 4. All right, so that wraps up activity 17. When we're looking at the ones for activity 18, the first 8 are matching a description with a graph. So I just am going to go through just a couple of them for how I knew which graph it was. So number 1 told you that it was an even function with no real roots, and it had a positive leading coefficient. So I'm going to look at my possibilities. Even function means that it has to be symmetric about the y-axis. So symmetric about the y-axis. No real roots means it should have no x-intercepts. And positive leading coefficient means that its end behavior either looks like this if it were even degree, or looks like this if it were odd degree. So I look at my choices, and first thing, it has to be symmetric about the y-axis. Well, this isn't, this is. So then I would look at my next qualification, which says no x-intercepts because there's no real roots. Well, that fails. This guy isn't symmetric about the y-axis, so I keep looking. Not symmetric about the y-axis. This one is symmetric about the y-axis. It also has no real roots because it doesn't cross the x-axis, and it does have end behavior that would be consistent with a positive leading coefficient. So that is how I got choice F. So this one was choice F. Another one that I am looking at, it says it's an odd function. Number 3, odd function. It says 1 real root, and it says it has a negative leading coefficient. So odd function means it has to be symmetric about the origin, which means if you rotate it 180 degrees, it should look the same. 1 real root means there should be 1 x-intercept, and a negative leading coefficient means that end behavior either looks like this or it looks like this. So I look at my choices again. Symmetric about the origin is the first thing that I need. So I'm looking, go back to the top of my choices. This guy, if I turn it 180 degrees upside down, that's not going to work. This one, it is. If I turn it 180 degrees, it would match up on top of itself. So this is symmetric about the origin. It says one real root. Well, this does. It has one x-intercept at 0. Then a negative leading coefficient here. Negative leading coefficient, yes, it does have end behavior consistent with a negative and odd degree. So that is how I came up with choice B. Last one I want to look at is number 7, which said P of x equals ax to the 5th plus some random things in between, and then it said minus f. So this tells you that because the a listed here is positive, that this is a positive odd degree. So that tells you what the end behavior has to look like. So end behavior on positive odds looks like this. So I'm looking for end behavior that looks like this. This negative f means that my y-intercept has to be negative. So I go to look at my choices. So end behavior, okay, that doesn't look like a positive odd. That doesn't look like positive odd. This doesn't look like positive odd. Keep going. D does look like it has a positive odd end behavior. So then I check the other. It says it has to have a negative y-intercept. Okay, so that's good. Oops, I think I said negative. And I think I said negative odd for some reason, so cross out D, no, because we're looking for positive odd. I looked at the other one for a second, sorry. So this has end behavior of a negative odd there, so that doesn't work. This one has the same end behavior, negative odd. This is a positive even, so that doesn't work. Going down to G, this does have negative or positive. I don't know why I keep saying negative. This does have positive odd end behavior. It does have a negative y-intercept. Also, because its degree was 5, I know that there could possibly be 4 turning points. 1, 2, 3, 4, and it does. So that is how I got choice G for number 7. All right, number 11 is your only graph on there. And again, now that we have done all of Unit 3, the expectation for a graph that you do by hand, remember you should have all of the x and y-intercepts labeled, you should have correct end behavior, and you have to have at least 1 point between each of your zeros. So the amount of work that you show has to be consistent with that. Again, this does not say you can use your graphing calculator. So this should be done, number 11, completely by hand. So when you look at the problem and you look at the original function, which was negative x to the 4th plus 11x cubed minus 21x squared minus 59x plus 70. The unfactored version here tells us the end behavior. Since this is a negative leading coefficient and it's an even degree, that means I know my end behavior looks like this. It also tells me I have a maximum of 4 x-intercepts. It also tells me that I have a maximum of 3 relative extrema, because n minus 1, so 4 minus 1 is 3. So max of 3 relative extrema. It also tells me that 70 is my y-intercept. So 0, 70 has to be my y-intercept. They did the factored form for you. So it looked something like this. So this tells you the x-intercepts, and that's what question 12 asks you. So I've already told you what the unfactored version tells you. The factored version tells you that your x-intercepts are at 1, 0, 5, 0, negative 2, 0, and 7, 0. So 4 x-intercepts, which is the maximum. So then when I go to draw it, you have to choose a scale that's appropriate, and I counted by 20, so on the Y, so I went 20, 40, 60, 80, 100, negative 20, 40, 60, 80, negative 100. I counted by ones on my x-axis, so 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6, 7. So I need to plot all of these points. So 1, 0 is an x-intercept, 5, 0 is an x-intercept, 7, 0 is an x-intercept, and negative 2, 0 is an x-intercept. 0, 70 is my y-intercept, so that's right here. And again, if you have the points listed next to your work, you don't have to label them on your graph. If you didn't list them right here, then yes, they need to be labeled on your graph. I know that these are all of my x-intercepts, so I know because my end behavior tells me that it goes down on both ends, that I know I'm going to have an arrow going this way after both of the last intercepts. Remember, you have to have a 0 between each of your x-intercept, or a point between each of your zeros. So I've got one here already because of that. Now I had found an additional one just because I wanted a more accurate height. So I had plugged in negative 1 to find how high that went. You need a point in between here, and we don't have one. So that's where you can either choose to plug a value in, or you can choose to use synthetic division. So I'm going to show you one of the synthetic division here because I think it's easier than using these big numbers to plug it in. So put a 3 in there because it's, you know, between 1 and 5. So my coefficients are negative 1, 11, negative 21, negative 59, and 70. So when I perform my synthetic division here, bring down my negative 1, box times bottom, write it underneath. This gives me 8. Box times bottom is 24. Add them together, it gives me 3. 3 times 3 is 9. Add the column here, gives me negative 50. 3 times negative 50 is negative 150. When I add that column, it's negative 80. So that means 3, negative 80 is a point on my graph, which is very helpful to me. Again, that doesn't mean that's the minimum. It means that it's a point in between. So there's that. So now I just need a point in between these two. I chose to do 6. Again, I did the same thing. I did synthetic division. I'm not sure I have room to squish it in here, but when I did my synthetic division, I got 40. So that means that the point 640 is on my graph. So I went up to 40. And again, that's not the relative maximum, probably, but it's close. And so that's how I got my very lovely looking sketch. Again, if you list the points, so if you list 3, negative 80, you don't have to necessarily label them on the graph. If you prefer to label them on the graph, that's perfectly fine. All right, almost done. Number 14a tells you to find the possible roots. So remember that we do that with the rational root theorem, which is P over Q. P are factors of the constant. Your constant term was negative 3. So its factors are positive and negative 1 and positive and negative 3. Your leading coefficient is negative 4. So factors of negative 4 are positive and negative 1, positive and negative 2, and positive and negative 4. So then that means our possible rational roots, you take each numerator over each denominator. So 1 over 1 gives us 1. 1 over 2 gives us 1/2. 1 over 4 gives us 1/4. So those three. Then do the same with 3. 3 over 1 is 3. 3 over 2 doesn't reduce, it's 3/2, and then 3 over 4. So here is your complete list of possible rational roots. 16a was having you use Descartes, so your original theorem or your original function here looked like this. So remember to tell the number of positive real roots, you look at the sign changes of this original. So this is positive, so when I move here, it's not a sign change, but when I move here, it is. So there's 1 sign change. When I move here, that's 2. There's 2 sign changes in my original, which means that there are 2 or 0 positive real roots. Remember, to find the negatives, you have to do h of negative x. So 2 times negative x to the third plus negative x squared minus 5 times negative x plus 2. This would give me negative 2x cubed plus x squared plus 5x plus 2. So the sign changes here. This is negative and this is positive, so that's 1. This isn't 1, this isn't 1. So there's 1 sign change in h of negative x, which means that there is 1 negative real root. All right, last ones. 19, I'm not going to go through the whole thing. I will get you started on 19. 19, you have to do the P over Q first, and your factors of the constant, it's 4, so plus and minus 1, plus and minus 2, plus and minus 4. The leading coefficient is 1, which means that 1, 2, and 4 are all your possible roots. So again, it tells you to use the remainder theorem on all of them. So that means 6 different synthetic divisions that you do to check to see which ones are zeros and which ones are points. So just like I did up here on 11, when I plugged in 3 to get a point in between my zeros. So if you don't get remainder 0, remember this is the y coordinate and this is the x coordinate. So that's how I got the points listed. If you do get 0, then that means it's one of the zeros. And that's how you do 19. 23 and 24, same idea. They're both not quadratic, they're polynomial inequalities. So if you look at our first one, we have x cubed minus x squared minus 36x plus 36 is less than 0. Now on 24, don't forget that you have to subtract the 32 to get it, so it's a 0 on the right side first. So next thing I want to do, I want to graph this in my graphing calculator, and I want to find the zeros. Again, it's your choice whether you want to use your graphing calculator to find the zeros or whether you want to do that algebraically. I'll show you algebraically because, of course, if you're doing it using your calculator, you'd be going to the second trace menu and choosing choice 2, which is zeros. If you're doing it algebraically, there is no GCF here, which means I would be factoring by grouping. So my first group here has a GCF of x squared. When I take that out, I get x minus 1. So I know my second group has to have x minus 1. What do I multiply x by to get negative 36? Negative 36. So this is x squared minus 36 times x minus 1. Here's a good example of something that factors once and then factors further. This is a difference of squares, x squared minus 36 is, because they both have perfect square roots. So your factored version looks like this, which means you have zeros at negative 6, positive 6, and positive 1. So you look at the graph in your graphing calculator, and remember, all I need on your sketch is a rough sketch of it. You don't have to put a scale on the axes at all. You need a rough sketch, so this guy looks something like this, and then you just have to label the zeros. So this one's negative 6, this one's 1, and this one's 6. So then once we do that, we look back at our original problem and we look at the symbol. This one said less than 0. So that means I'm going to highlight the parts that are below the axis. And remember, anytime I'm highlighting an arrow, it's just a plain old symbol. So the value here is -6. So since it's below that, it's going to be a less than. So x is less than -6 is our first part that we get from this arrow. When we have any sort of loop, remember that means that there's going to be a sandwich. So x is going to be between, and then you look at the loop. What are the boundaries? They're 1 and 6. So those are the boundaries on your sandwich. And that is your final answer. All right, that wraps it up. Again, please prepare for your embedded assessment by actually trying to do the embedded assessment after you've watched this, and make sure you study for your Unit 3 test.